Okay, so that's about that time. We'll kind of move camera now, see how that goes for these videos. So if you have any questions out of 2.1. Okay, so 2.2, we'll get into functions and graphs. Okay. All right, y'all. So first thing I'm going to refresh y'all on domain and range. Remember, your domain basically your set of all the x values. We call it the independent variable. And basically, when you got a function, you can look at the domain as all the input values. Because one thing about the domain, it cannot contain, so it cannot contain values that make the expression undefined or imaginary. And I'll tell you, the way you're going to get things that are undefined is fractions. If you got a variable on the bottom of a fraction, you put a 0 in, that's going to make it undefined. And then your imaginary numbers come from radicals, like trying to take square roots of negative numbers. Okay. And from a range, basically going to be a set of all the y values. It's the dependent variable. What I mean by that, the dependent variable depends on what numbers you're putting in for those x values to get them y values out of them, okay? All right, so we want a function. All right, so a function, to be a good function, each one of those x values can have one and only one y value, okay? So each, oops. Oh, hang on. X value. So each x value can have one and only one y value. Right, I want to put one number in, get one number out of that. I can't have a choice. So if I put a number in and it gives you a choice, then it's not a function. Okay, function has one input, one output. So you've probably heard of it. When we check functions on graphs, so when checking a graph, we use what we call a vertical line test. And I'll explain that more when we hit that, but all we're going to do, if you can run a vertical line left to right across the graph, if it intersects it more than once, it would not be a function. That means you'd have an x value and have a choice. Okay? All right, I'll just show you some examples that you're going to see in the first part of this. Okay? So we're going to determine if a function. I'm going to draw a little here. All right, so my domain values are 18, 21, and 14. My range values are 21 and 7. I've got an arrow going straight across. Arrow from 21 to 7, and then from 14 to 21. So remember, for that to be a function, each of these x values, which is my domains, so that'd be your x, y. Each of those x's can have only one y value going to. So is that a function? Definitely. All right, so we look over here, 18 only goes to one number, 21 only goes to one number, and 14 only goes to one number, okay? Just like a paycheck, right? You work so many hours, 20 hours, you know what you're going to get paid for 20 hours. You don't want to have choices on that, though, right? Actually, when you got a y value like that, it's got two different x's. To me, that'd be something like a salary pay. Hours differ, but that pay is always going to be this, whatever that salary was. Okay. All right, so another picture with the domain range. So y'all have -3, 1, and 7. My range is a 3. So all three of them pointing over there at 3. So is that a function or not? Yes. It's still a function, right? Each one of my x's only has one y value. So you got really
We can't hear anything.
Testing, testing.
I can hear you now.
I can
Okay.
hear you.
Yeah, I guess these big fancy mics they put in here and not picking up too much, right? All right, y'all, let's go into what we call function notation. And you'll find a lot of this little first chapter 2 we're doing is sort of like a lot of, oh, what do you call it, refreshing y'all from stuff y'all might have seen, right? So when I talk about function notation, I'm talking about f of x, right? And really, if I was going to explain that, to me, that just means we're replacing the y variable with the f of x to denote a function. And it gives me the chance that whatever number I put in for that x tells me what number I'm going to be putting into the entire function, okay? So, function donation, if a value is put in place of that x, then that value is substituted into the expression. You know, do this all the time, especially with paycheck probably. You know what you make in an hour. So you can figure out how much you would make after, say, 20 hours. So we'd be finding basically your P of 20, which would be pay for 20. So that 20 in there for the hours, multiply by the rate of pay, and that'll give you that output or answer, right? Well, y'all seen the f of x before. In here, even a lot of times when they're graphing, they'll do the traditional table with an x and a y up there. You pick your x values and then find the y values. But they'll also put an x, and instead of a y, they'll use an f of x. So get used to the f of x and the y being the same thing. The only difference is if I had a y there, I'd have to say, hey, find me the value of this expression when y was 5. Where function notation, I can say, hey, find me f of 5. I think it's mainly just shorthand type stuff, y'all. I'm going to give us a function h. So given h of x equals x plus 13. So we'll go through different letters in here, F's, G's, H's. But if you get into a science class, the H would probably mean something for maybe height or something. Usually they're named with what they sort of go for in the formulas. Okay? All right, they want us to find H of 0, H of -1, H negative 3, H of 7, and then finally H of a C plus 15. So we got what, 1, 2, 3, 5 things they want us to find. So we'll start out with h of 0. So since they now have a 0 in here for the x, I need to take my expression, and when they got an x, I'm gonna put that 0. So that h of 0 will be 0 plus 13. So h of 0 equals 13. Okay. Same thing, h negative 1. We'll take that original expression, x plus 13. Replace that x with my negative 1. And see, they did a couple more negative numbers than they did positive, because they know y'all like to forget about your rules for adding unlike signs. So negative 1 plus 13. Okay, so unlike signs, just subtract the numbers and get the sign of the larger number, right? All right, h negative 3. That'll be negative 3 plus 13. So see, you'll get that's within unlike signs, right? So that's gonna give me. All right, they hit me with what? Positive 7. So let's see, h of 7. So 7 into that x, I'm gonna get a 7 plus 13. Well, they add like signs, add them and keep that sign. So 7. There we go, 20. So the tricky one to be that c plus 15, right? So I want to find h of c plus 15. So guess what I'm putting in for that x? C plus 15. But remember, I still got the plus 13 at the end. So you still got a big X plus 13 there. What y'all doing to that? Well, first question, the C is not going to add to the numbers, right? So that C is just going to come down. But y'all can add that 15 and that 13 together. So just go back to like terms, right? So let's see, that'll give me what, a C plus? 28. Can you go any further? No, so we're going to stop there. So we're still going to see if y'all remember them rules for like terms, right? So far, so good, right? All right, question online. What about this? I'm going to try f of x equals x to the third. We will find f of 0, f of negative 1, f of 4, f of 8, f of negative 2, and then finally f of a negative 3a. All right, so let's see, that's what, 6 of them they want us to do. But really, they're just trying to ride these excellent rules on you. So I want to start with my f of 0 equals 0 to the third power. Big O 0, right? Right, that's -1, same thing. But y'all will say if you negative numbers to an odd exponent, you don't have to really watch as much. But if that's a negative number and that's an even exponent, and you do them on them calculators, I would put them in parentheses. I would put my -1 in parentheses and then square it so it'll know to take care of the negatives, okay? So basically, this is a -1 to the third power. So negative times a negative times a negative. That's going to give me what, a -1. All right, F of 4 is going to equal 4 to the third power. Oh, that's already getting a little big, ain't it? 4 times 4 is 16. And then 16 times another 4. 64, there you go. Now, hey, if you want to do these on a calculator instead of doing like 4 times 4 times 4, on this problem, you would use the 4 on the right side. You see what I call a caret, looks like an upside down V. And then you would put in the 3 and hit enter, and it'll spit out that 64 quick. Okay? Ooh, here's an even bigger one, y'all. F of 8. So 8 times 8 is 64. And then 64 times 8?
12.
512. So let me see, I had what, 8 to the third? 512. Okay. You know, these exponents can make numbers get big quick. Okay. So we got an f of a -2. So that'll be -2 to the third power. So once again, we know that will be definitely a negative. And then 2 times 2 times 2. So we get about a -8. Okay. I always say the best one for last, right? That -3a. That's going to equal -3a to the third power. So that exponent affects everything in them parentheses. So we got the negative times negative times negative will give me a negative. How about 3 times 3 times 3? I got a -27. And then what's going to happen to that a? A to the third. A to the third. So remember, it's like the a has an exponent of 1 by it, and we're just multiplying the 3 times 1 to keep that exponent, okay? Or just remember, a times a times the a, you would add all the exponents to make that a to the third, okay? All right, let's see if y'all recognize this formula here. I'm going to do f of c equals 9/5 c, so 9/5c plus 32. What's that formula for?
Fahrenheit and Fahrenheit.
Fahrenheit in my Celsius, right? So what we want to know, what Fahrenheit temperature, so what Fahrenheit temperature is equivalent to a -15 degrees Celsius. basically, I'm finding f of a negative 15. I guess we're in America, we should be doing the other way, right? Finding Celsius temperatures from the Fahrenheit. All right, so let's put the negative 15 in for the C. So I got the 9/5 times negative 15 plus 32. So when I did this problem, I was always happy if the number they gave me to put in was a multiple of that fraction's bottom, right? Because if it wasn't, otherwise we'd have to put a 1 here, multiply this, and then get something over 5 and try to add to a 32, which means you've got to find common denominators and all that. But y'all, when these numbers are multiples of these denominators, I'm going to cancel that and figure out what negative 15 divided by 5 is. That'd be a negative 3. So now, instead of playing with a fraction, 9 times negative 3 is going to happen there. And then we'll add that 32 to that, right? So 9 times negative 3 is what, a negative 27. Plus, I bring down my 32. So, negative 27, positive 32. So did we get 9? Positive 5. That makes sense. Because I know Fahrenheit 32, Celsius is 0. So since my Celsius is in the negative numbers, that means that Fahrenheit definitely got to be below that 32, right? All right, y'all got them powerful calculators too. You can just plug these numbers right into it and spit them out quick. Okay? All right, so now we're going to graph some more functions. And really want y'all to get used to them tables. And in these examples, they're going to pick the x's and we got to get the y values and then be able to graph them, okay? So this one, I'm going to graph f of x equals negative 4x plus 2. And do no calculator, you punch that negative 4x plus 2 on that y equals and it'll spit it out quick, okay? All right, so let me see what numbers they wanted me to use. So now they're going into the x and the f of x notation. So they want y'all to realize that they are y's, okay? So they're giving me 3 values, negative 2, 0, and a 2. Now, y'all, I know this is a straight line. It only needs 2 points, technically. They're giving you 3. So when you graph it, you can only use 2 of them points, okay? They do 3 points because if 3 points are in a line, that verifies your accuracy. And that's all they're doing with that 3rd point, okay? So, first I'll find f of a negative 2. That's the first x value they gave me, right? So that'll give me negative 4 times negative 2 plus 2. So really, when you're evaluating these expressions, you want to follow your PEMDAS. Right? Knock out parentheses first, then exponents, multiply and divide, and then add and subtract. So I got negative 4 times a negative 2. Negative times negative is definitely a positive. That's gonna give me a positive 8 plus 2. So that'd be what, a positive 10. So the first point I'll plot in MATLAB would probably be my negative 210. Then they want me to find f of 0. So that'll be negative 4 times 0 plus 2. And y'all, anytime you're playing with zeros, anywhere there's a letter, it's going to be a 0, right? So basically the answer would be 0. If I got a 0 plus my 2, that's 2. So when x is 0, my y value or my f of x is 2. And then finally we got to put a 2 in, so we're going to find f of a positive 2. So negative 4 times 2 plus 2. And I really think they're trying to mess with y'all with signs and stuff in these first few sections. So negative 4 and 2 is what, a negative 8? Negative 8 plus a positive 2? Negative 6. All right, so let's see, I think I can get that right here. So, maybe if I was doing this by hand, I'm thinking these bottom 2 points, because 6 is a little smaller than that 10. But I think MATLAB actually goes out to about 10 by 10 on them graphs, so that'd be all right on in. All right, so my 0, 2, starting at 0, I would go right up 2. And we know that because that's my y-intercept basically in the y equals mx plus b form, right? All right, then 2, negative 6. I'm going to start at the center again, go right to the 2, and then down to my negative 6. You know, if you'd have done the other point, negative 2, 10, it would have been up here, but it still would have been a straight line for that, okay? So it looks straighter on MATLAB, or on your calculator, right? Or if I had graph paper. So questions on any of those yet? We don't got to anything down, did it? All right, f of x equals negative 3 plus absolute value of x. Now the video, I sent out a video the other day doing some of these MATLAB problems in the calculator and in MATLAB. I showed you how to get the absolute values on that, okay? And let me see what numbers they want. Ooh, 5 numbers on this one. So negative 2, negative 1, 0, 1, and 2. And really the reason they're doing 5 on this one, so y'all can see what we call the symmetry to it. So y'all, I'm going to start out doing f of negative 2. That's going to equal negative 3 plus absolute value of that negative 2. So whatever's inside those absolute value lines, to remove them lines, the sign of anything in there will be, once I bring it out, it's going to be positive. So remember, they're just finding distance. Okay. So to that, 3 miles north is the same as 3 miles south. They're still the same distance from that zero, okay? So this now becomes a -3 plus 2. And then -3 plus a 2 will give us a -1. Now notice, I did the absolute value first, because the absolute value has the same priority as parentheses. Okay? So that means you got to get them out before you can move into your other operations. I already got an f of -1. So that'll be -3 plus absolute value of -1. I'm going to bring my -3 down. Absolute value of -1 is 1. And then we got what, -3 plus 1? Will give us a -2. All right, what was next? F of 0. So that'd be -3 plus absolute value of 0. So absolute value of 0 is 0. And then that -3 and 0 give me a -3. So now y'all want to start seeing a little what we call symmetry to this. Oh, what's next? F of 1 is going to equal -3 plus absolute value 1. That'd be a -3. So what is the absolute value of 1? It's still a 1, right? So notice, whether that's a -1 in there or a +1 in there, it will come out as a 1 for both of those. Okay? Remember, absolute value don't care about signs, it just cares about how far you're from that 0. All right, -3 plus 1 is going to give me a -2. So see what's happening now? You got -3 in the middle. On either side, you got -2s. What y'all think will be right there?
-1.
Probably -1, right? And it's all because those absolute values, whether they're negative or positive, are giving you the same numbers, okay? So -3 plus 2 would give me a -1. Okay? All right, anytime you see the absolute value in MATLAB, you want to use the absolute value tool. And it looks like a V with 2 dots on it, which means you got to plot 2 dots on it, right? So the first point you got to plot is that what we call the vertex point. You know, after that, you can pick any of the other 4, plot for the second point, it'll draw the whole V for you, okay? All right, so if I do the math, I have my 0, -3, here's 0. So I would go down 3, put my -3 on the y-axis. Got to be the first point you plot. Now, I can pick any of the other points. So I'm just going to use the 1, -2. I'm going to go right 1 and down 2. That'll put me right there. But you could have went -1, down 2, same thing. So let's see what else I got. I got a 2, -1. And over here I had -1, -2. So notice they do make a nice little V there, huh? That's because all these negative values of x's are going to have the same outputs as all these positive x's, okay? Okay, so pushes on the absolute value. Let's see. I guess we got time for one more. Let's see. All right, here we go. F of x will equal negative x squared minus 2. Negative 2, negative 1, 0, 1 and 2. So anytime they're giving you 5 numbers, they really want you to see the symmetry they got. You know, I'll tell you what, that negative being in front of that x squared makes this probably the trickiest one I'll be on the board today. So watch what's happening. I'm going to do f of negative 2. So the expression starts out with a negative. You got to write that negative. Then you're going to put in your x. Well, my x is a negative 2. So I'm going to put my negative 2 in parentheses. And then I'm going to square it. And then at the end, I'm going to subtract 2. So no matter what x you're putting in here, it's got to have that negative in the beginning. So that was up here in the formula. Now, do not make that a positive 2. Can't multiply yet. First thing you got to do to this one is that exponent. So this negative, I would just bring it down. So what is a negative 2 squared? So negative 2 times negative 2?
Negative 4.
Oh, it's close, but it's a
Positive.
positive 4. But with the negative in the beginning, it's going to basically keep it negative. All right, then we bring down that minus 2. So now technically that negative that was sitting there is multiplied by that 4, making it a negative 4. So what would be a negative 4 minus 2?
Negative 6.
Negative 6. All right, then I do the same thing with this f of negative 1. That's going to equal negative 1 squared minus 2. So I'm going to bring down that first negative again. I'm going to figure out what negative 1 times negative 1 is. So my negative 1 times negative 1 will be 1. So I'll bring that down, but I still got that negative out there. So I'm going to make it a negative 1. And then at the end is your minus 2. All right, so negative 1 minus 2. Negative 3. So let me put that in. Now the zeros are easy because you put the 0 where all the x's are. That becomes a big 0. So you got a big 0 minus 2. So that's going to give me my minus 2. All right, so we're going to throw the 1 in now. So we will find f of 1. So now, since this is my 4th and 5th points, we should start seeing the symmetry happening to this. So this would be negative 1 squared minus 2. Now, if you want to put the 1 in parentheses, you can, but your calculator knows that this negative is not being squared because it's not in parentheses. So bring that negative down and figure out, 1 times 1, so that I get a -1, and then bring down my -2. And we already know what -1 minus 2 is. That's going to give us a -3. So I'm pretty sure we know what's going here, right? So let's say officially we got what, f of 2. So that'll be my negative times 2 squared minus 2. All right, so we'll bring that negative down again. Get the exponent first. So 2 squared. 4. So it gives me what, a -4 minus 2. So that should be matched up over here to my first one. So we know that's going to give us a -6. So since that's an x squared, in MATLAB, this would be a 3-point quadratic tool. So it is picky. Once again, the first point has to be that vertex point. Now notice it's got the dot here and then 1 dot on each side. So as you plot the vertex, you got to plot one of them 2 points and then come up here and plot one of them 2 points. Okay. So altogether it needs 3 points, center, and then left or right, and then the other. Okay. Hey, question on that? Y'all want me to do the graph? And they're being nice. They're keeping the numbers fairly small for us. All right, well, first point would be the 0, -2. So that'd be right here. Because what happens if you plot one of these points first, say over here, so say I did 1, -3, if I did that point first, it would treat that like the vertex. And any other points I added, it would shoot it from there instead of where I need it from, okay? So I got my 0, -2, then I can go over here to 1, -3. At that point, MATLAB would still have a straight line, but once I jumped on this side and did my -1, -3, after that point, it would come in and draw a parabola. Okay. All right, questions on those? So just giving y'all like a refresher. All right, so before I jump out here, I'm going to give y'all determine if these are functions. Okay, so let me draw one more. How about a parabola that shoots out like that? I got 2 pictures. One of them is a function, one not. So I don't have to do no math to this. I just got to get a vertical line. So this is what I've shown y'all, that vertical line test. If it's a function, my vertical line cannot intersect my graph more than once. Okay. So my graph here is a V. So notice it's only intersecting at once everywhere I go on this one, right? So this never intersected it more than once, so the first one is definitely is a function. So this one is my yes. So if this hits it twice, it's not. So I'm coming to my second graph. Bam, I hit that up here and down here, all along this, right? So since this one's hitting it twice, this is no. So think about this. All these X values got one Y value. So look at these X values. This X value has two Y values. This one has two Y values. So remember, the X's cannot have a choice, okay? All right, so that ought to get y'all through 2.2. So I'm going to end this, and then if you got support, we'll go over there and get y'all fixed up in that next class. Okay. And the main thing, have y'all done y'all's course agreements? Okay, because that's the main thing, that if those aren't done, they make us drop you off and all that. So. All right, any questions on mine?
Do we just stay here for support?
Say again?
Do we just stay on here for support, or do we like?
I'm going to be going to another room, so I'm going to cancel this out, but then y'all get right back on over there when I pull it up.
Okay,
Okay? So I'll see y'all in about 5 minutes.
thank you.